So you hear these terms all the time, right? Deep learning, neural networks, they get thrown around everywhere. And honestly, they can sound super complex, maybe even a little bit like magic. But what if I told you the core idea is actually surprisingly simple? Yeah, let's break it all down together over the next few minutes.
All right, so let's get right to it. What is a neural network, really? Let's just, cut through all the jargon, all the hype, and get right down to the simple, powerful idea that's actually running the whole show.
Okay, to get our heads around this, let's just forget about huge, complicated AI for a minute. Let's think about something way simpler. Let's talk about selling t-shirts. Seriously, we're going to build this whole thing up from just one single foundational brick.
So imagine you're running a t-shirt website. You know this from day one, right? Price and demand, they're connected. If the price is super high, well, not many people are going to buy. But if you lower that price, sales start to go up. It's just simple, intuitive economics. We all get that.
You could even, draw this out. As the price creeps up, the number of people who want that shirt, it goes down. And of course, demand can't go below zero, right? At some crazy high price, literally no one is buying. This simple line, this little function, that's our starting point. And here is the kicker, the surprising part. What we just described, that little function, that is the simplest possible neural network. No joke. This tiny machine that takes in a price and spits out a demand, that's an artificial neuron. That's our very first building block.
Okay, so if that one neuron is our first Lego brick, what happens when we start stacking them, right? Let's see how this thing starts to build.
And you really got to hold on to this idea because it's the key to understanding everything else. Think of one neuron as one single Lego brick. It's kind of useful on its own, but it's limited. A neural network? Well, that's what you get when you start clicking hundreds or even thousands of these bricks together to build something way, way more powerful.
Because let's be real, in the real world, it's never just about the price, is it? T-shirt sales are affected by all sorts of things, like shipping costs, how big your marketing budget is, even the quality of the cotton. Suddenly, our simple problem just got a lot more complicated. So the question is, how can a system possibly take all of these different inputs and somehow combine them to make one single accurate prediction about demand? Yeah, you can't just draw a simple line on a graph anymore, that's for sure. Well, the solution is actually pretty fascinating. The network creates these layers of what you could call middle manager neurons. They don't predict the final sales number directly. Instead, they learn to figure out more abstract ideas. So, for example, one neuron might look at the price and the shipping cost and figure out a score for affordability. Meanwhile, another one is looking at the marketing budget to calculate customer awareness. And this right here brings us to the most incredible part of deep learning. You might be thinking, okay, so a human has to program in those concepts, right? Someone has to tell it what affordability is. But nope, that's not how it works at all.
See, this is the absolute game changer. For decades, programming meant a human, a person, had to sit down and write out all the rules. We'd have to figure out exactly how to combine price and shipping to create some kind of affordability score. But with deep learning, we don't write the rules anymore. We just give the network point A, all our inputs, and point B, the actual sales numbers. The network itself then figures out all the complicated stuff in the middle, completely on its own.
So the most important thing to get here is that you don't tell the network what to look for. You just show it the data, thousands and thousands of examples. The software's whole job is to automatically tweak the connections between all those Lego bricks. It keeps changing the strength, or what they call the weight, of each connection, again and again and again, until it finds the magic combination that best predicts the right answer. It is literally learning from experience. Now, our little t-shirt example, it only used a handful of neurons. But just so you know, the real-world neural networks, the ones used for stuff like language translation or analyzing medical scans, they can have thousands or even millions of these neurons all firing and working together. Okay, let's pull all this together. Let's make a clear, simple blueprint. How does this whole process actually work from start to finish? It's really just 4 steps. 1, you start with those simple units, our Lego bricks. 2, you connect them all up into a network. 3, you feed that network a ton of data, all your inputs, point A, and all the correct outputs, point B. And then 4, the magic step, the network itself just automatically tunes all its internal connections until it learns the complex pattern between A and B. So really, at the end of the day, that's what neural networks are. They're just systems made of really simple parts. But
When you connect enough of them together and you give them enough data to learn from, they can figure out how to compute incredibly complicated things, finding patterns that no human could ever sit down and program by hand. It's wild. And that really leaves us with a final thought, doesn't it? If a network of these simple little neurons can learn something as tricky as predicting t-shirt demand, what else can it learn? I mean, what happens when the input isn't price, but all the pixels in a photograph, and the output isn't a sales number, but a person's name? The possibilities, they're just staggering to think about.